over. Are we not going live?
सर स्टार्ट कर दीजिए आप.
Okay, Bismillah. Okay, yesterday we started discussing the best time to buy and sell stock, and we had a couple of good questions coming from the students. Our moderators tried to address those, and but I think there's still a need for us to go through this problem line by line and understand. The approach we'll be using for this problem is a two pointers algorithm, similar to dynamic sliding window. But I will not get into the conceptual discussion about what these algorithms are. I'll just implement this. I'll show you how these things work. Okay, so let's get at the problem now. You are given an array of prices, where prices of I is the price of a given stock on ith day. So what they're saying is that the array that you're being given, that array contains prices, okay? Where if you take a value on the index of this array prices, which will be prices of I, that will give you the price of the stock, price of the stock, price of the stock at a given day. And your day will be the ith day. Okay. Now, in terms of array, we start indexing with 0, 1, 2, 3, 4, 5. But there's no such day as 0 day or 0th day, right? So we will consider this first element as the first day. So day 1, day 2, day 3, day 4, day 5, and day 6. And a better way to do that, consider that is for easy visualization is you consider this Monday, Tuesday, Wednesday, Thursday, Friday, Saturday. Okay. So since we're going in the sequence of the days in a week, it can be a single 1 week, or it can be it can have multiple weeks, it can have months or years, right? When talking about large data, because if you scroll down and look at the constraints here, if you look at the constraints here, what you see is that the prices of the prices, um, the digits themselves, or sorry, the price is the length. The length of the prices array can be up to 10 raised to power 5, which is, I think, 100,000, right? If I'm not wrong. And 10 power 6 would be a million. Please correct me if I'm wrong here. But yeah, you can have so many days, you can have months or years. And if you take even a larger set of data, you'll be dealing with even a larger set of data. Okay. All right. So now that we have seen that we have days in a week, now can we buy something on Tuesday? I have a question for you. Can we buy something, and ping that in the chat? Do not unmute yourself. Can we buy something on Tuesday and sell it on Monday? Is this possible? Please post your message in the chat. Is it possible to buy something in the future and sell it today or yesterday? No, it's not possible, right? So since we're dealing with the constraint that we're talking about days, right? And we are talking about selling our stock on a different day in the future, then that means we have to go in a single direction. We cannot say that I can buy my stock at the second day and sell it at the first day. So we have to keep this rule in mind, okay? And this description is already inside this statement. You have to read the statement. So what are they expecting us to do? You want to maximize your profit by choosing a single day to buy one stock and choosing a different day in the future to sell that stock. There are a lot of details in here. Pay attention. You want to maximize your profit, which means that, let's say, even if you arrived at a profit, which is, for example, 5 minus 1. This is a profit. You bought it for 1 and you're selling it for 5. You bought it for $1, for example, and you're selling it for $5. It is profit. But given that you have a data set where you're not bound by a strictly ascending or strictly descending order, you can have other possibilities where, let's say, you can buy it at 1, you can still buy it at day 1, day 2, and then sell it at 3, 4, day 5th. And 6 minus 1 will give you even a bigger profit than 5 minus 1. So now you have maximized, now you've increased. But again, it's not the absolutely maximized profit. You have to keep looking, you have to keep searching, right? You have to keep looking, you have to keep searching, and you have to make sure that you're getting the best maximum possible. So this entire question is to find the best maximum profit. Okay? By doing what? By finding the best day to buy and best day to sell. And how will we determine that? Where when our sell day minus buy day and the value that the subtraction gives us is greater than all other subtractions of sell and buy dates, then we have truly found our maximum profit. And that is where we'll return our maximum profit. Okay, so let's continue reading. By choosing a single day to buy one stock and choosing a different day to sell that stock, not buying another stock, but the same stock you're buying, on a single day and then you're selling it in the future. Return the maximum profit you can achieve from this transaction. If you cannot achieve any profit, return 0. So all you have to do is from this transaction, the transaction that you're going to do after finding the best day to buy and best day to sell, we'll return the maximum profit. And if we cannot achieve the maximum profit, we'll return 0. So how is this possible that we never ever are able to find the maximum profit? That can happen in a condition, in a situation where we have a descending order, a strictly descending order, where, for example, 7, 6, 5, 4, 3, 2, 1. If I buy at 7 and sell it at 6, right, I'm still at a loss because I'm losing $1 here. Let's say if I buy it at 2 and sell it at 1, I'm still at a loss, right? So I'm losing completely. So there is 0 profit in investing your money here. What about a strictly ascending order? 1, 2, 3, 4, 5, 6. In that case, it's very easy. Get your first index, get your last index. That way you can make sure that you can sell at the first day and, buy the first day and sell the last day. Okay? So keep these things in mind. We cannot go back in the day. We have to explore the maximum profits where we have a possibility that we do not have a strictly ascending order. In descending, of course, we're not getting any profit. But where we are sure that we can have cases where we have mix of bigger and smaller numbers. In that case, you have to explore all the numbers and make sure that you have the maximum profit. You have found the best maximum profit out of that. Okay. So now let's move to the code part of it. But before we go there, what is the approach we can take to explore this data and find the maximum profit? Okay. So let me write down some key points. First thing is that we have to maximize the profit. Okay, which means keep looking for a better maximum profit. Okay, that's one thing, one observation. Number two, a best day to buy can change if the best day, if the day to sell, if the day to sell is less than the day to buy. And I'll explain this in a second. Number 3 is once you have found one day to sell, keep looking for another best day to sell. Conclusion? What's the conclusion? Keep finding better days to sell, or better day to sell, I would say better day to sell, and better day to buy. And actually, it's going to be easier to understand if I do it this way, even though they're both are correct. Keep finding better day to buy and better day to sell until all data explored. Okay. And then we should be able to change our better day to buy and best day to buy and best day to sell based upon if we find a better day to buy and better day to sell. So let's say, expanding upon this point number 2, best day to buy can change if the day to sell is less than the day to buy. By this, I simply mean that initially when I thought that 1, 5, 3, 6, 4 in this example, that I found the best day to buy, and then I have a best day to sell. What if I had a 0 here? And 0 is less than 1, right? So even if I'm finding a best day to sell, even if I determine this is the best day to sell after 5, the best day to buy would be 0 instead of 1, right? So we have to keep looking. And this we can explore when we are finding the uh, maximum, the bigger day, right? When we're finding the bigger day to sell, the 0 will come on the way, and then we can catch that. Okay, now that we have a better day to sell, now the day to, sorry, better day to buy. Now the buying date can move here, and sell day will be, of course, after this. So then sell date should go here. But what if my maximum profit could only be derived from here? What if after 0 we have other zeros? What if 5 is, after 5 they're all less numbers? Well, in that case, since I've already calculated the maximum profit, I'll just return this as an answer, right? What if I find a better maximum? Then I'll choose that maximum and I'll just cancel this one out. Okay. All right. So let's move into the implementation, how the code is going to look like. I'm going to post these 4 points in the chat. Okay. Let's see if I can pin this somehow. I can't pin this. Anyways, so those points you can refer to if you don't understand something uh, before we get into our discussion. So I'm going to remove this. I'll reset my page. That's fine. I'm using Java again. Sorry. We can convert it to Python code as well if needed. But for now, we'll just stick to Java. Okay. So I'm going to define a few basic data types, basic variables. One is maximum profit that I need to find. Okay. And then I can define a variable that will tell you about the day to buy. Okay. Day to buy. And then I'll define day to sell. Okay. Day to sell. And since I know that my day to sell will always come after day to buy, so can I say buy day plus 1? Well, sell day is equal to buy day plus 1. Okay. Now, instead of using nested loops, I was thinking about using nested loops where, I can keep resetting I and j, but I can use a single loop, and I can still use two iterators where I have I and j, but in this case, I'm considering them as pointers where only single loop can move both of these pointers based upon conditions, based upon operations, that whenever my buying date is greater than the selling date, then I move my buy date to sell date, and sell date will move to the next one. And then I keep moving my sell day, where sell day starts with 5, then moves to 3, then 6, then 4. And then I keeps moving until it arrives here at this point. Same concept, right? The only difference is I'll have to put two conditions. One is if my buying date is greater than the selling date, I have to switch my values. I have to select the next value. Secondly, if my um, okay, if I find a better buying date, let's say if my selling date, in that case, let's say I moved my I here because it's a better day to buy, and this is my J. I calculated a one maximum profit. Then I move my J. And let's say if I found a zero here instead of, um, clarify. Let's say if this was, let's say if this is zero. Okay. Instead of 3, this is 0, and this is 6. I moved my I here. I moved my J here. Next, I explore J. Now, I'm seeing that my day to sell is less than my day to buy, right? Then what I should do is I should move my day to buy again, right? And then the day to sell will start from here. Again, this in that case, 0 and 6 will give you the um, best maximum profit. Okay, 6 minus 0 equal to 6. So that's the logic I'm going to use. It's going to make sense after I implement this. If not, we can discuss it. Okay, so let's move on with our implementation. I want to use a while loop. And in while loop, I want to say that if my buy day, sorry, I want to run this loop until my sell day, my buy day arrives at here and sell day goes down here. I don't want my buy day to come at the sell day. I cannot buy and sell the same day because I have to sell at a different day in the future. Okay. So what if I have my buy day go until prices dot length minus 2, and sell day, I want it to go all the way to the prices dot length minus 1. Sell day goes all the way to the end, minus 1, and buy day goes minus 2. Then I check for a very specific condition. What's the condition? If my prices at the buy day, and the price at the buy day is less than my prices at the sell day. This is good, right? No worries there. If my prices at the buy day is less than sell day, then I can find a profit, right? Whether it's maximum or not, that I'll determine later. So what I do is I record my maximum profit by doing certain operations. What's that operation? That operation is prices at the sell day minus prices at the buy day, right? But what if I find a better maximum? In that case, I can use an existing internal Java function, math.max, and compare it with already recorded max profit. And whichever value is bigger, it will just record that and keep that as maximum profit. Okay. Now, right now, the maximum profit is 0, and the prices of sell minus buy, this is 1 minus 5. Okay, 4. So 4 is greater than 0. In that case, 4 will be my current maximum. 4 and 0. 4 is greater than 0, so max profit is equal to 4. Okay, now in next iteration, what I'll do, okay, once I have found my maximum profit, now I need to look for another day to sell if I can find a better day to sell. Because right now I'm thinking I found the best day to buy and I found a good day to sell, but can I find a better one? Well, in that case, I will look for, I'll increase my sell day, which means I'll move forward here to find another sell day. Okay, it's same as J++. If I'm at J+1, I'm moving my J iterator. All right, okay. Now let's say if my sell day is less than my buying day. If my sell day is less than the buying day, which means the same example of 0. Instead of 3, if I have 0, then if I'm trying to sell it at day 3, it's already less than buying day. So then I improve my position with regards to buying. Okay, so now I'll use else condition. And instead what I'll do, I'll use a different logic. I'll switch around. What I'll do is I'll assign the value of sell day to my buy day. Okay, and then I will move sell day, which will be equal to buy day plus 1. Okay. If my selling day is this, then my buying day will be this. And then I'll come here, right? Now that this logic has been executed, right? I'll come here and then I'll compare. Right now my I is here and J is here. My buy is here and sell is here, right? I and J. And the maximum profit was 4. What is 3 minus 6? Sorry, 0. This becomes 0. Forgot to change that here. So I already have a maximum profit 4 from here that we stored earlier. And now we have 0 minus 6, or better to say 6 minus 0. So now, which is greater? 6 is greater than 4, right? So now I will store 6 at the maximum profit. Okay, so now my maximum profit is this. Now, once my iterator comes here, and then my I is still here, right? Since it hasn't found something less than 0. So 0 minus 4, or 4 minus 0, well, this equal to 4, and 4 is still less than 6. So anyways, that's how we found our maximum profit. So last stored maximum profit will be this right here. And just the final finishing touch will be returning the maximum profit that we have found so far. Let me clear all these drawings. Return maximum profit. Okay, so now I'm going to submit my code. First, I'm going to run it to see if it passes for basic 2 cases. Well, it did. And if I submit this, it should pass for all 212 cases. If we analyze the time complexity, oops, I already used one. It's going to be O of n. And the reason it's O of n is this while loop, it does not move I and j at each iteration by 1. Instead, it moves it intelligently based upon these conditions. So these conditions, each operation is O of 1, right? O of 1, right? And sometimes this will get executed. But this will explore the entire array, this while loop, which is O of n, the total number of arrays. So plus, 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 plus. These get disregarded anyways. This is the worst case scenario. So your total time complexity is O of n. And you can even check that. I analyzed with this one, it worked. It said yes, it's O of n, confirmed. Well, I'm glad we were able to finish solving this question in just half an hour. Now you guys can go ahead and start asking question Please raise your hands before you ask so people can get their turns accordingly. Any questions? I guess none. In that case, okay, someone has put something. It's clear. Okay. Well, in that case, I'll hand this meeting back over to Sarasat or Sarah Zubair Zafar, and I'll let them lead rest of the session. Thank you.
अस्सलाम वालेकुम, कैसे हैं आप लोग?
वालेकुम सलाम। ठीक ठाक सर, आप कैसे?
अल्लाह का शुक्र। सर मैंने फर्स्ट टाइम ज्वाइन किया है। इस टाइम पे मेरे जहन से निकल जाता था कि सेशन का टाइम है और कुछ और काम होते थे जिसकी वजह से मैं ज्वाइन नहीं कर पा रहा था। तो कोई शेयर कर सकता है कि कहाँ तक हम पहुँच गए हैं और क्या प्रोग्रेस जा रही है इस टाइम पे? आई थिंक ये थर्ड डे है, राइट? या फोर्थ है?
ये है फोर्थ डे।
जी।
सर मैं ही बता देता हूँ क्योंकि लास्ट 4 सेशंस मैंने कंडक्ट किए हैं। तो let me share my screen again and we can go over what we have done so far. तो हमने सेशन स्टार्ट किए। इनिशियली तो ये डिसाइड किया मैंने कि रियली enthusiastic, तो मैंने अपना नाम ही सब में डाल दी क्योंकि no one had occupied this column, right? Uh, I gave introduction to data structure and algorithm, time complexity, space complexity को मैंने नहीं डिस्कस किया फॉर फ्यू रीजंस। और मैंने टू सम का प्रॉब्लम इनको मैंने एक ब्रूट फोर्स अप्रोच और ऑप्टिमल वे टू सॉल्व दिस टू सम प्रॉब्लम दोनों हमने डिस्कस किए। और कंटिन्यूस डुप्लीकेट वाला प्रॉब्लम हमने कल डिस्कस किया था। बेस्ट टाइम टू बाय एंड सेल स्टॉक, ये वाला जो प्रॉब्लम है इसको कल हमने डिस्कस करना स्टार्ट किया था बट वी रन आउट ऑफ टाइम बिकॉज अ लॉट ऑफ स्टूडेंट्स हैड क्वेश्चंस। वी स्लाइडेड इनटू अ डिस्कशन और आज इसको मैंने इम्प्लीमेंट करके फिनिश कर दिया है। इसका मज़ीद ऑप्टिमल तो मुझे सोल्यूशन फ़िलहाल नहीं पता, लेकिन आई थिंक दिस इज़ ए बेटर अप्रोच। नेक्स्ट क्वेश्चन मैं ये वाला डिस्कस करने वाला हूँ, प्रोडक्ट ऑफ वेरी एक्सेप्ट सेल्फ। But yeah, everyone is requested to kindly start picking at least one question and assign your name to it. The more you present, the better you're going to learn and understand these concepts. So this is the entire uh, recap of what we have done so far.
अमेजिंग प्रोग्रेस सर। मैं सिर्फ इसमें एक चीज़ बोलूँगा कि बाकी लोग भी साथ वॉलंटियर करें प्रेजेंट करने के लिए। तो उससे एक तो ये होगा कि आपको प्रेजेंट करना आएगा, ना सिर्फ आपको प्रेजेंट करना आएगा बल्कि आपके इंटरव्यू के स्किल्स बिल्डअप होंगे। आपको कम्युनिकेट करना आएगा किस तरह से आप एक टेक्निकल रिक्रूटर को क्वेश्चन प्रेजेंट कर रहे होते हैं। और सर ताला आप लोगों को ये अपॉर्चुनिटी दे रहे हैं कि आप आई गुड गुरु के प्लेटफॉर्म पे अंग्रेजी जुबान में इंग्लिश के अंदर भी कम्युनिकेट कर सकें। तो मैं हाईली रिकमेंड करूंगा कि इनमें से कोई भी क्वेश्चन जो आप प्रेजेंट करना चाहते हैं, प्रिपेयर इट। अगर मैं ये ओपनली रिक्वेस्ट करूंगा कि कोई भी प्रेजेंट करना चाहता है तो वो आगे सेशन में रिक्वेस्ट कर दे। तो यू गाइस शुड हैव द अपॉर्चुनिटी टू प्रेजेंट एनी क्वेश्चन।
जी बिल्कुल।
तो जजाकल्ला सर फॉर रीडिंग इट। आई बिलीव इससे काफी लोगों को फायदा होगा।
जी सर, मुझे बताते खुद मैं अपने आप को इंट्रोड्यूस एज अ स्टूडेंट ही कराया मैंने। इवन दो वी नीडेड अ ट्रेनर फॉर दिस सेशन, तो अल्हम्दुलिल्लाह आई एम गेटिंग दैट अपॉर्चुनिटी। लेकिन एट द सेम टाइम आई एम जस्ट अ स्टूडेंट लाइक यू गाइस, आई एम आल्सो लाइक प्रीटी न्यू टू डीएसए। तो इसमें ऐसा नहीं है कि यू शुड फील लाइक ओके वी नो लेस और इवन इफ यू नो मोर। क्योंकि कल मुझे बहुत सारी चीज़ें पता चली। टाइम कॉम्प्लेक्सिटी के बारे में मेरे कुछ कॉन्सेप्ट स्टूडेंट्स ने क्लियर किए विच आर बेसिकली माई, आप सब लोग कोलीज हैं एक तरह के। और इसके साथ जो है तो सॉर्ट का जो एक फंक्शन डिस्कस किया था कि मेरा आइडिया ये था कि सॉर्ट फंक्शन जब भी आप इनबिल्ट फंक्शन यूज़ करेंगे तो ऑफ एन स्क्वायर कॉम्प्लेक्सिटी उसकी, क्योंकि नेस्टेड फॉर लूप यूज़ करके आपको वो सॉर्ट करके देगा। बट देन आई थिंक मुझसे नाम भूल
लॉग
गया।
एन से।
जी सॉरी
आई थिंक जो सॉर्ट फंक्शन है वो लॉग एन
जी
कम्प्लेक्सिटी में
एन लॉग
क्रिएट
एन
होता
जी जी एन
है। जी
लॉग एन।
एन लॉग
तो मैं असल में वो मोहतरमा ने फिर मुझे करेक्ट किया, बहुत बहुत शुक्रिया, उनका नाम मुझसे भूल गया माजरत से। तो उन्होंने बताया कि नहीं ये एन लॉग एन है, और इवन वर्स के सिनेरियो में भी एन लॉग एन ही रहेगा। तो तब वहां पे मुझे एन लॉग एन क्लियर हुआ, और कैसे ये कॉम्प्लेक्सिटीज ऐड होती हैं मुझे भी इतना अंदाजा नहीं था, सिर्फ बेसिक पता थी। तो लेट्स कीप दिस सेशन टू बी समथिंग लाइक इट्स लाइक अ peer डिस्कशन, बट ऑफ कोर्स क्योंकि हम लिमिटेड है 1 आवर तक, तो वी ट्राई टू स्टे फोकस एंड ट्राई टू सॉल्व एज मेनी प्रॉब्लम्स एज वी कैन।
जी सर, जजाकल्ला।
ओ
तो
या
इसमें एक ही चीज़ मैं ऐड करूंगा कि आई कोड गुरु के स्टूडेंट्स हैं वो 100% सक्सेसफुल इस वजह से होते हैं क्योंकि हम सारा का सारा कोर्स जो है वो इंटरव्यू स्टाइल के अंदर कर रहे होते हैं। लाइक इट इज़ अ मॉक इंटरव्यू एवरी डे, एवरी सिंगल डे यू कम हियर, प्रेजेंट अ क्वेश्चन। अगर आपकी कोई चीज़ गलत है तो आपको करेक्ट किया जाता है, आपसे काउंटर क्वेश्चंस किए जाते हैं। तो लर्निंग जो है वो एक्सपोनेंशियल हो जाती है इस सेटअप के अंदर। तो जी सर, आपने ठीक कहा कि ना टाइम लिमिटेड है, तो हम प्रोसीड करते हैं। सर इफ यू वुड लाइक टू टेक लीड प्लीज, अगर कोई और करना चाहता है तो वो बता
मैंने कोई
सकता
क्वेश्चन प्रिपेयर तो नहीं किया, दिस वन इज इन प्रोग्रेस, ये प्रोग्रेस सब मेरे प्रीफिक्स सफिक्स वाला। तो अगर इसी को हम डिस्कस करें तो कर सकते हैं इसको, एटलीस्ट डिस्कस तो कर ही लेंगे इसको, इफ दैट्स ओके। फुली प्रिपेयर नहीं है, बट एटलीस्ट आई कैन गिव व्हाट आई हैव अंडरस्टूड सो फार।
है। जी सर, श्योर।
ओके सो दिस क्वेश्चन मीडियम लेवल का क्वेश्चन है ये। So we need to find the, no, that's not it, is it? Okay, yeah. So we need to find the maximum product subarray. Okay. So first, I think we should explore what a subarray means. A subarray can be a single element inside your array. It can be your entire array, right? It can be your entire array. It can be a number of elements in your array, or it can be a single element. And does empty array count as a subarray as well? Or that would be a subset? Can someone clarify on that? It shouldn't, right? Because when we're dealing with array, we are talking about a size, and size means there has to be something. If we're dealing with an empty array, well, of course, now our size is 0. So that itself is a subarray of itself, but it's empty. But this should not be, an empty array should not be a subarray of this. Okay, so the question is, given an integer array nums, find a subarray that has the largest product and return the product. So if you're given an array nums, you need to find a subarray that can give you the largest product, which means if you multiply 2 by 3, if this gives you 6, and if 6 is the largest product you can get out of multiplying the elements inside the array, that will be your largest product. And that's what you need to return. The test cases are generated so that the answer will fit in a 32-bit integer. So the test cases, the way they have written, they've been written in a way where your answer will be a 32-bit integer. It won't be a big integer. Big integer in Java is especially where it can include even, I think, 64-bit integers. So you have to return your answer in 32-bit, so which means they're looking for an integer data type to be returned. Okay. For other languages that are not statically typed, such as Python, you may need to take care of that constraint. Okay. So let's look at this. 3 multiplied by 2 equal to 6 has the largest product. In this case, the result cannot be 2 because -2, -1 is not a subarray. Okay. Okay, one thing we need to keep in mind is that we are keeping in mind the indices. So a subarray cannot be something like 1 and 3. This is not subarray. These are distinct elements. So when you're talking about array, we're talking about the consecutively stored elements on contiguous memory spaces, 0, 1, 2. So if you're taking subarray, you can consider this, or you can consider this entire thing. So this seems to be like a sliding window, sliding windows problem where we have to use a dynamic pattern. So I'm thinking that we multiply 2 and 3, okay? And then we extend our window. If the last product is greater than the new product, we still keep that. We shrink our window and we move here, okay? Or we move this one all the way to the end and then we shrink window. So in that case, first we're multiplying 2 by 3, and then we're doing 2 by 3 by -2. But since now we're going in the backward direction, so what we do is we shrink our window. We shrink our window until we start getting a bigger maximum, a bigger product. Uh, and once we have reached the end of the window here and here, and if we can't find any better product, then we'll return the last better product. I think that's how it's. Sorry, am I going in the right direction? I think Asad has something to say. Asad Hashmi. Please go ahead.
Sir, I need to ask that if we are getting more numbers in a multiplication row, in a multiplication operation, the more number are there, the larger product we are going to have. So if we only need to figure out the toggling signs. Like if we need to take the negative signs and even. Like if the integer included in the array are uh in the negative, so we just need to count that.
Mm-hmm. Good point.
Is my approach correct or is there something else in this?
No, I think it's a valid point. However, I'm thinking, what if we're not dealing with decimals, right? We're just dealing with integers. So
Yeah,
we cannot have something like 1 by 2 somewhere it will get reduced. So you're
yeah,
saying that we are only dealing with the negatives and positives with integers.
yeah. Because matlab, as we increase the numbers in multiplication operation, it will just increase the result. So we
Right.
cannot have a sub-array for two indices that can exceed the value for three.
What about 0?
Yeah, so if the value is less than one, so
Hmm.
we need to exclude it or we need to consider those values.
Right. But at the same time, like I said, in an array, you have to go in a fashion where you are going consecutively, right? So you're not picking and choosing single numbers. Also, you're not sorting, I believe. I don't know if they have given a constraint where you cannot sort, which should not matter actually. It's a product, right? Even in addition, it should not matter. Also, we're not dealing with the problem like the last one, where we have a strict sequence of days. So you're right. We can definitely use this as a condition to solve this problem. So for dynamic sliding window, if we are taking product, right, 2, 3, now we hit a negative number on the one end of the sliding window, right? Once we had the negative, what should be done in this case? It will keep decreasing. If I keep going like this, it'll keep decreasing, right? So I will store this so this doesn't get lost, and I'll move I'll move this end of my window to this. Still, it's not giving me a good answer. Then I'll go this way, and now that I have hit the limit, I need to have at least two. I need to have at least two elements to get the product. But remember, we cannot just exclude this because we're talking about subarrays. And subarray can be a small array of an array, and the array cannot be non-contiguous. As someone raised their hand, please go ahead and share your thoughts. They should be next to each other. Yes.
Sir, I need to ask is that we will have two variables to hold the data. One will hold the consecutive
Yeah,
multiplication and one will hold the largest possible output.
you're right. Let me, uh, I can do I haven't done
ओके
Python.
सर, हमारे साथ सर जुबैर जफर भी ज्वाइन किए हैं, तो सर जुबैर जफर आपको अस्सलाम वालेकुम सर, के साथ
वालेकुम सलाम।
कुछ पॉइंट्स हैं, अगर किसी को भी क्वेश्चन है तो सर जुबैर जफर है तो काइंडली पूछ लीजिएगा।
जी,
आप
थैंक यू
कुछ
सर
ऐड
फॉर
करना
मेंशनिंग।
चाहें, आप
जी जी,
कुछ
मैं
ऐड करना चाहेंगे
अभी
सर?
अभी काफ़ी चीज़ें ऐड करके हटा हूँ सर। अभी अभी आपने ज्वाइन किया है तो
नहीं सर,
आई थिंक।
मैंने ज्वाइन किया था, नेट इंटरनेट इशू की वजह से वो डिस्कनेक्ट हो गया।
अच्छा अच्छा, चलिए कोई बात नहीं, थैंक यू फॉर मेंशनिंग। तो अगर किसी को कोई क्वेश्चन हो तो फील फ्री टू आस्क इन द मिडल।
Okay. Um, what I'm thinking is, if my window, I can basically what I'm doing here is I'm slicing the array. You guys know about slicing? Slicing a list. See, we have list here in Python. I'm using Python because the thing's going to be easier to think in this. Um, I'm using a starting index 0, and then I'm using an ending. So I think again I should apply the same. I should make my ending index as starting plus 1. Starting plus 1. Okay. And then I should increase. Again, I think I can apply the while loop, right? While ending index, while ending index is less than or equal to nums dot length minus 1. Is that the correct function in Python? Length minus 1. If this is less than length minus 1 and starting index is less than or equal to nums dot length minus 2. Again, the same INJ concept. Okay, I need to check for a few conditions. If, okay,
Sir, someone has shared correct syntax in chat.
length nums, okay, length nums minus 1 and minus 2. Thank you, Saklan. Length minus 1 and length minus 2. I think that's going to work. Okay. Okay, one thing is that we are we can increase the ending. We can multiply first. First, we need to multiply to get a product. Okay. Max product will be equal to the nums at starting index, right? Multiplied by nums at ending index at ending index. Okay. Once if we have gotten product, then we see if the maximum product, if the max product is not negative number. If max product is not a negative number, let's annotate this. So I have multiplied these two. Okay. I have a maximum product at 6. Now I need to increase my window. So for that, what I have to do, I have to increment ending index as 1. I've stored a product, and now I have to increase my ending index. Okay. So after calculating, ending index plus equal to 1. Okay. And the condition I have to look for if the product is not, if the max product is greater than, like Asad said, if the maximum product is greater than 1, right? Greater than or equal to 1, what we have to check. Then in that case, we will include the next maximum product. So I think somehow we should evaluate this maximum product, the first one, and then check if it's greater than 1, greater than or equal to 1, right? Before we even start the loop. So in that case, we can just take this, or we can take the, this is wrong. This is a list, so we have to put square brackets, right? We have to put the square brackets. So we have to see if initially, if this is so maximum product is greater than 1, and the, okay, that's one condition. Next condition should be if the number at ending index, if this is greater than 1. If this is less than 1, then my window should move. My window should shrink, actually. Maximum product is greater than or equal to 0. Ubaidullah, could you explain this? Max product is greater than or equal to 0.
So it can be 0 in second example, and greater than 0 is will which not equal to in negative values. So that's why I use greater than equal to 0.
But if it is 0, then it will make others 0. We don't want that, right? So we have to have it at 1 or greater than 1.
Greater than 0 is also will return greater than 1 in any value without calculating negative values.
You're saying if maximum product is greater than or equal to 0. Greater than 0, yes, you're right. If it's greater than 0, it's already 1. But what if
Yes.
it's equal to 0?
Yes, sir.
And that's a problem, right?
So if equal to 0, so it will return just like in second example, you can say that it will take negative value, some other value, so that why it will equal to 0.
No, I think why it's 0 is because of the 0, no? So what if let's say if we have an example where 2, 0, and 1. What is the maximum product we can get? We cannot get any product here because we're talking about a contiguous memory locations, right? So if we can go like this, we can go like this, we can go like this, but we cannot go like 2 and 1. Makes sense? If you're talking about subarray, you cannot change this because this is the array that you've been given. So if you get a 0 in between, then you're already at a disadvantage. It's same as like if you have 2 multiplied by 3 multiplied by 4, and then in the middle someone put a 0, your whole effort is gone. Even anywhere you put a 0, I think. So anywhere your maximum product is evaluating as 0, you're at a disadvantage. I think it's better to return a 0, unless someone can give me another example. If anyone has a counterexample. So I think that 1 is still very strong. Anyways, I think we have like few minutes left, so I will try to see if I can just solve this part, like how should our pattern move. I'm actually kind of stuck here. 2, 3, -2, and 4. So if I have these values only, -2 and 4, I'm taking a product, but now I've hit a negative maximum product. So if my maximum product at any position is less than 1, in that case, I should do an else condition. Instead of this, I'll do else condition. Okay, at least we can solve this part. Else, what we can do is move our ending index plus equal to 1. What about starting? Should we shrink our window if we hit a negative? Because let's say if you hit a negative, now we have to find the next positive one, right? Else we'll keep going until the end of the array. Yes, if you have all positive, we can keep going until the end of the array. If we hit a negative, then we have to somehow skip that. So for us to skip that, we have to find the next positive number after the negative one. But the only fashion we can do that is if or we can skip that. Why do we even need to just keep going like this, keep shrinking? So the way we'll shrink is like if you hit a negative, just put your starting index here on the next positive unless you find a positive, and then again you start. And then that's how you'll return the maximum product by comparing same thing I did with the math.max. You can use the same formula there. I think we have only 4 minutes left. I just don't want to, if anyone has any closing remarks or anything, Zubair or anyone. But I think we have a solution now. I feel like we can get there.
Sir, I think they are asking about the maximum product, not
Right.
greater than zero value. So maximum product value could be, for example, if the one product is equal to -4 and another product is -2. So in this case, -2 will be maximum product for us. So they do not say about the not take negative value or negative something like that. So I
Okay.
think maximum product could be any value.
Right. You're right, because we forgot to check the constraints actually. You're right. If you see here, it can be -10 and 10. So in that case, we can keep computing and we can keep shrinking, not on the base of skipping negatives, but we'll keep exploring. Anytime or what we can do, I'm
We
thinking.
just store the first time a maximum value in a max variable, and after that we will check all the array. If that value is greater than any value found, we greater than that value, so we can choose and just return that two values from which we got the product of greater value. So this is the actual answer, I think.
Oh, okay, hold on. So you're saying explore the entire array, keep storing the maximum, better maximum, right? And then shrink the array once we have hit the end. And that's how we have explored all the negatives and positives. And then we'll have the best maximum product. That means we can attempt this on our own. I think it's enough. We've only 2 minutes left. I'll just close this for now. Yeah. Thank you, Ubaidullah. Thank you, Saknan. Thank you, everyone, for giving me this opportunity. This means a lot. Sir Zubair or Sarasa, you guys can go ahead and give a closing remarks for today's session.
ओके थैंक यू सो मच फॉर पार्टिसिपेट्स एंड किसी को भी कोई क्वेश्चंस हैं तो सर जुबैर जफर हैं तो उनसे काइंडली पूछ सकते हैं, अदरवाइज हम सेशन को एंड कर देते
सर जुबैर जफर, अस्सलाम वालेकुम सर।
वालेकुम अस्सलाम।
सर ये लीड कोड पे जो हम प्रॉब्लम सीखते हैं ना, तो अगर फॉर एग्जांपल हमने यहाँ पे सीख लिया या यूट्यूब से सीख लिया, तो हम इसको सेम टू सेम सॉल्व करेंगे या इसको तो हम चेंज कुछ नहीं कर सकते? ज़्यादा से ज़्यादा हम वेरिएबल के नेम चेंज कर सकते हैं या इस तरह कर सकते हैं। फॉर एग्जांपल एक काम वन लूप से और आए तो इसको हम तो मजीद ऑप्टिमाइज नहीं कर सकते हैं।
जी सर।
सर मेरा
मैं
क्वेश्चन ये
आपका
था,
क्वेश्चन नहीं समझा। जी जी।
फॉर एग्जांपल एक प्रॉब्लम है, उसका जो है
हाँ,
टाइम
मैं इसमें
कॉम्प्लेक्सिटी।
पर्सपेक्टिव शेयर कर देता हूँ ड्यू टू
जी
कंस्ट्रेंट ऑफ टाइम।
जी
होता ऐसे है कि ना, कोई भी लीड कोड का सवाल है, उसके मैक्सिमम मिनिमम दो सॉल्यूशंस तो होंगे और मैक्सिमम चार भी हो सकते हैं।
ठीक
तो
है।
ये अब डिपेंड करता है कि आप कौन सी वाली वीडियो देख रहे हैं।